PN junction. Or PN junction diode. PN junction diode. Now what is a diode? Till now we came across many electrical components. We came across capacitors which store charge. We came across resistors which slow down the current, right? Which is using electrical component which provide resistance to the circuit. Then we have learned, after that we have learned meter bridge, potentiometer. We have learned cell also. What is a cell? How does a cell work? We have learned that. Then we have learned potentiometer devices. We have also learned galvanometer. What is a galvanometer? It's working on which principle? This device we have learned. Then we have learned the meter bridge, potentiometer. That thing definitely is there. Then we have learned voltmeter. What is a voltmeter? What is an ammeter? And how does a galvanometer? How they are made from the galvanometer only? We have learned. Then all these components are very rudimentary, very fundamental in our in engineering, you say, in electrical engineering, you say, in physics, wherever you go, these are the concept, principle, physics, whatever is, everything is so fundamental that today's modern physics is standing on these things, these principles. Now we'll get introduced to another set of electronic devices that revolutionize the world, which have already got introduced to semiconductors. Now, why did we learn so much of semiconductor in our last videos? Did we classify semiconductors in terms of energy band diagram? What is p-type and n-type? The reason is we are now progressing towards to develop another circuit component which will revolutionize, which changed the whole world. Let's see what is it. A diode. Now you have seen in a resistor that when a current, if this side is positive, this side is negative, current will be flowing from positive to negative only. Okay, fine. Now if you change the polarity, you connect this to the positive terminal of the battery and this side to the negative terminal of the battery, then also you will see that it is delivering current, no problem. But diode is such a component, as the name suggests, diode means biased. It allows conductivity only in one direction. If you connect in one particular way, it will be acting like a conductor, and if you connect in the other way, it will act like a resistor. So let us see how this mechanism work. So a PN junction diode, when a p-type semiconductor and an n-type semiconductor is joined, then the arrangement is known as PN junction diode. PN junction diode, and the junction separating the junction that separates p-type and n-type is called PN junction. So let's see what happened. You take a p-type semiconductor in which majority charge carriers are holes, and you join it with a N-type semiconductor. Join it with the N-type semiconductor. This is P-type, this is N-type. When you join it, what will you see? This is plus, plus, plus. These are all plus, 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 plus. All majority charge carriers are holes, and in this case majority charge carriers are electrons. So as soon as you join them, this arrangement is called PN junction. Now when you join them, some mechanism will take place, some drifting of holes and electrons on the either side across the junction will take place, and as a result something will happen. As soon as a P-type and an N-type semiconductor is joined or fused, the holes in the P-type and electrons in the N-type diffuse across the junction. By diffusion, what do I mean? The electron will move, the electron will follow here, and holes will come here, will diffuse across the junction. Definitely vacancy is there, electron will try to go there, it's a empty region, so it will try to fill that gap, so it will jump from across the junction, will diffuse, N-type diffuse across the junction. Consequently, a layer of electrons on the P side and a layer of holes on the N side appears with few more. So what do I mean is, let me draw the diagram once again. So if I draw, you see so this is P, this is N. This side is holes, and a layer of electron now appears here, and here on the other, consequently a layer of electrons in the P side, I must say here, a layer of electrons on the P side and a layer of holes. Oh, I have written, sorry, and a layer of holes on the N side, and a layer of holes on the other side appears. So this means there are some holes here, and these are electrons. after few layers of diffusion, after few layers of such diffusion, what will we see? We will see that there are few subsequent layers of electrons in the p side and few subsequent layers of holes on n side has appeared. So initially when we have joined, we will find some current in the circuit. We will find some current constituted by the PN junction. So if we join them to some resistance, we will see we will see ammeter, we will see some current, very instant current for a while, but then it stops. Why does it stop? You can see now that as soon as we join them, the electrons from the p side, the holes from the p side and the electrons on the n side, they diffuse across the junction and the electrons start diffusing. That means, what do I mean is that I'm just showing you one layer. After this it will diffuse here, it will diffuse here, and so on. If you join them, we can see some current in it. So like this, electron will move from n to p, and similarly the holes will move from p to n. But after few layers of diffusion, what will we see is that there will be no current. After few layers of diffusion, this current will stop. Why? Now if an electron which is in the n side want to diffuse with this hole, it won't be able to do. Why? Because it will be repelled by this electron. Why? Now a negative voltage has appeared here and a positive voltage appeared on the n side. This potential difference is called potential barrier. Because of this potential barrier, it will not be possible for electron to overcome this potential barrier and diffuse on the p side. Similarly, it will be difficult for our holes on the p side to cross this potential barrier and diffuse on the n side. This region up to which the potential barrier has now extended, has formed, is called the depletion region. Depletion region. So what we say like that. So what we can say now is that, so the holes on the p side and n side appears with subsequent diffusion of electron hole pair across the junction, the layer of electrons in the p side, the layer of electrons in the p side and the layer of holes in the n side widens. This in turn creates a potential difference, creates a localized potential difference across the junction. Which prevent the further diffusion of electron hole pair This potential difference is called potential barrier. Potential barrier and the region up to which it is active, up to which it extends, is called depletion region. So this is called the depletion region. So you can say like this also. How I have said, you can change it and you can say that as with subsequent diffusion, electron hole pair diffusion, a layer of electrons, few layers of electrons appear on the p side and few layers of holes appears on the n side. So this layer, after this, no further division takes place. So these layers are these opposite charges near the junction. This layer of opposite charges near the junction, we call this as the depletion region, up to which it is it extends. Now because of this, the diffusion current completely stops. Also note, the n side has become now positive and p side has become now negative. So an electric field now exists from n to p. An electric field now exists from n side to the p side. Also, due to potential barrier, an electric field is set up from p side, from n side to p side. The thermally generated electrons which do not depends on doping and are minority charge carriers in minority charge carriers. Where is the minority charge carriers? In P, holes are the majority charge carriers. So in there, N is the minority charge carrier. Minority charge carriers in P diffuse minority charge carriers okay, let us not give, because they are produced in both, they do not depend on any one of them. Minority charge carriers, so the electric field is from positive to negative. So an electron will always drift from negative to the positive. So if the whole current, the electron was, if you see, the diffusion current is from this way. That means holes is moving this side. The diffusion current, if you take the direction of the holes as our diffusion current, so diffusion current is from P to N. Okay, and in case of drift one, the drift is from drift will be in the opposite direction. So the minority charge carriers depends on the doping, and minority charge the thermally generated electron which do not depend on doping and are minority charge carriers drift in the opposite direction of diffusion current. So there are two kind of current, as we can see. One is the diffusion current, another one is the drift current. So drift current is actually goes from N side to the P side. So you can see this diffusion current, diffusion is from P to N and drift is from N to P. Definitely, because as you can see, this side is negative, this side is positive, so it will be moving in the holes will go from holes will be going towards, they completely depends only on the diffusion. The minority carriers depends only on the temperatures, they do not depend on doping. So the temperature of the surrounding is large, they will be created more and they will cross the junction, right? So you can understand like this way, that the electric field that exists between N to P means, we know positive to negative means this is the direction of from positive to, this is the electric field direction. So that means holes are moving this way and electrons are moving from negative to positive. So an electron, so in P side, electrons are the minority charge carriers. So when they are formed, although I am giving it as a general sentence, they will be formed in N side as well, but in N type it is extremely less, and P side also is extremely less, but let us consider on the P side. The electrons on the P side will get what? It will be pushed towards the N, and the holes will be pushed from the N to P. But these are prepared due to thermally generated electrons, not by the doping. Because of doping, the conductivity has already stopped because of the formation of the two or many layers on the either side of the junction. So no diffusion current takes place anymore. As you can see, diffusion of holes takes place from P side to N side. But in case of drift, the thermally generated electrons that are produced, they will be moving from, this is holes. We are talking about the holes, so don't get confused here. We are talking about the holes, conventional direction of current. Okay, so you can see that the electric field, I will introduce it, I will write it here. Also, due to the potential when the electric field is set up in the N side and P side, the thermally generated electrons which do not depend on doping and are minority charge carriers drift in the opposite direction of diffusion current. Correct? So that is, the electric field pushes an electron towards the N side and a hole towards the N side from P, because from P and a hole towards P type and a hole towards P type from N. Remember this. This is the drift current. This is called the drift current. So this current is called the drift current. This current is called drift current. So as you can see that whenever we join one P type and N type, what will happen? First of all, they will diffuse, means holes will move towards the N side and the electrons will come from N to P. As soon as they join, they will attract each other, and remember they are nothing but energy levels, transfer of electrons from one energy level to the another. So that will take place. As a result, hole will be created in the holes will be created in the one atom to the one atom's outer shell to the other one. It will be moving like that. So remember the bond structure as we have learned. So then this diffusion current takes place. But then what happens is that after few layers of diffusion, no further diffusion current will take place, because even if the electrons from the N side want to cross the junction and reach the P side, it will be prevented by the negative potential that is present in the P side near the junction. So it will be repelled. As it gets repelled, it won't be able to go there. So diffusion current completely ceases. So initially we will see there is a little bit of current and then current stops. But however, let's say the surrounding temperature is varying, is changing, is increasing. The semiconductors are good conductors at the higher temperature, room temperature. So if it's increasing, then electrons which are mildly charged carriers at P type will be developed, will be generated. So they under the attraction of this positive potential, means these holes which are present there, they will attract it, and they will drift towards the, although it will be very little, almost negligible, but it will start drifting across the junction. So some hole concentration at the N side near the junction will reduce, and some electron concentration near the junction in P side will reduce, but it will not get thin or it will not get reduced completely. It will take place, but it will not completely break it. The potential difference across this junction is called the potential barrier, and the region up to which it is extended is called the depletion region. Now if you increase the depletion region more, widen it or loosen it, it is a good conductor, and if it is very wide, it is a bad conductor. If it is thin or it is break, it is a good conductor. If it is very wide, it is a bad conductor. So that is what we can do now. We can connect the PN junction diode in such a way that it will become a forward bias, it will become a conductor, and in another connection which is called the reverse bias connection, it will become a resistor. Okay, so this would be our forward biasing and reverse biasing for PN junction will be our next topic.